Hey YouTube, I'd like to share this video about my very first Tesla coil. I built this guy in 1997. It's 2017 and it's been 20 years of tinkering with Tesla coils and exploring electronics and engineering. And yeah, so let me just power it up and show you the coil in action. So it's a bipolar Tesla coil, has the two electrode terminals here, salt water capacitors, spark gap made from a fuse holder and a bolt and a screw, oil burner ignition transformer, and I built this just through tinkering and sort of a natural selection rather than intelligent design, swapping out caps, adjusting turns of the coil. But now, 20 years later, I have some more sophisticated instruments like my function generator and oscilloscope and custom high voltage probe I built, and we're actually going to take some measurements on this Tesla coil. So what I have here is my function generator, and I have it hooked up with a little two LEDs back to back, and I'm going to sweep the frequencies and see where this small Tesla coil has its resonant frequency. So I'm going to adjust this dial here and tune it in, and we'll see where the LEDs glow the brightest. So it looks like 2.2 megahertz. So if I tune it up, so 2.3, LEDs are off. Bring it back down. We get the brightest glow of the LEDs. It's like 2.24 megahertz. The resonance frequency of this coil. So now what we're going to do is hook up our high voltage probe across the capacitor bank, and we're going to see the charging, discharge, and oscillation frequency of the capacitors and primary coil of the Tesla coil. Alright, so I got my high voltage probe hooked up across the capacitor bank. Got one lead attached here to the aluminum foil on the outside of the saltwater capacitor, and have the other lead attached to the top of the capacitor. And I'm going to slowly turn up the power to the Tesla coil on this variable transformer, and you can watch the oscillations on the oscilloscope. So we see our 60 hertz power frequency, and if we zoom in, we can see we get roughly two charge-discharge cycles per positive transition and negative transition of the AC sine wave. And I'm just going to zoom in. And right here is where you see the spark gap fire and that Tesla coil discharge. So let's try to zoom in even further in time. See if we can see the oscillation of the Tesla coil. So we're able to measure one oscillation cycle of that spark discharge, and it measures 2.3 megahertz. And we made our resonant frequency was about 2.2. So we're pretty pretty close. And I'll just zoom out in time so you can see where that spark gap discharge occurs in time relative to our 60 hertz sine wave. Zoom in. So 20 years later, I was able to capture the oscillations of this Tesla coil on the oscilloscope. So, took long enough. Catch you later.